So going through integration homework 2, the answers, I'll put them up here, but if you want me to go through anything, just stop me and I'll go through it. So question 1a should have been 69 and 1/3.
Is that the same as 208 over 3?
Yes, it probably is. Yes. It's 73 is 210, so yes, it probably is. Okay, so that's for that first one. Any questions, queries about that? Okay. Part B, 2. Part B, 2. Part C, I got 3 1/3. However, the book I got it from says something different, but I can't see how they got it. And Brian, you're nodding at 3 1/3, are you? Sorry? 10 over 3, okay. The book got 0.83, don't know where that came from. 3 1/3 is what I reckon it was. D, 44. And E, 4 2/3. So that brings the first question to a finish. Question 3, and I'll start going through some of these problem ones in a bit more detail. Question 3, we had to find this area up here. And first of all, we had to find the coordinates of A and B, which were the points of intersection. So to find the points of intersection, let's get rid of that bit of paper a minute. To find the points of intersection, I put the curve equal to the line. Then I moved these things here on the right hand side of the equal sign to the left hand side. That got me a quadratic equation, which I was able to factorise, and I got the solutions 1/2 and 2 for x, which tells me that that is 1/2 on the x line, and that is 2 on the x line. Remember, I'm after this shaded area up here. So what I've got over here is that if I include this rectangle down here that I don't want, and I called that rectangle bit S, if I integrate between 1/2 and 2, because I get the area under the curve, if I integrate between 1/2 and 2, I will get R and S added together. And that's the integral of the curve between those limits. So what I'm going to do now is I'm going to do that integral to give me what R and S is. Then in a minute I'm going to work out that area of S, which is a rectangle, and just take that off that answer. So if I do that integration over there, that came out to be 4 1/8. That is R and S added together. And then the rectangle is 1 1/2 wide, and it's a height of 2, so it's got an area of 3. And if you take that 3 off the 4 1/8, you get to 1 1/8 for your final answer. Anybody want to say anything about that?
That's the same as 9/8, isn't it?
Same as 9/8, yeah. Okay.
How many marks?
I haven't really thought about marks, man. Perhaps we'll come back and go through marks at the end. Is that okay? Next question, question 4.
How do you know where the half comes from, sorry?
The half. Which half? The half, this half.
Yeah.
That comes from solving the quadratic equation you get. If you put those two equal to each other, you get that quadratic equation, factorises into 2 brackets. The half comes from here. Because either 2x minus 1 equals 0, which gives you the half, or from that one you get the 2. Okay. Question 4, which is our third question. We have to sketch this graph first of all. Okay. It's a cubic graph. Cubic graphs always look like that or like that. Pretty much they do. That one is one where the x cubed is positive. It goes that way round if the x cubed is negative. So it's one of those. And it crosses the x-axis at 1, 0 and minus 1. 1, 0 and minus 1. Were you able to get that sketch done? And again, if you've got a graphics calculator, you can just type it in the exam and it will pop it out for you, so you can see what it's like. If I just go through how we could do that bit a minute, if I just find another bit of paper. If we had the equation to us in bracket form, the equation was given to us like this. We've got to find out first of all where it crosses the x-axis. It crosses the x-axis when y is equal to 0. So just like solving that quadratic equation, if you put that equal to 0, then if you have two things multiplied together which are equal 0, either the first one has to equal 0 or the second thing you're multiplying has to equal 0. So we have here x equals 0, or over here that means x squared would equal 1, so x would equal the square root of 1, which is where x is minus 1 and plus 1 comes from. So those are the points it's going to cut the x-axis, at minus 1, at 0 and at 1. And because you know it's a cubic which is that way round, because it's a positive amount of x cubes, you can just go up there and then down and then up again. So you can get your sketch looking like that. Okay. If you didn't manage to get that though, you might have had some trouble with the rest of the question. But carrying on with that one, what we had to do here, we had to find the total area. I just use this curve here. So that would be that area and that area. And because they wanted the total amount of area, you can't just integrate between minus 1 and 1, because this is a positive area, this is a negative area, because it's below the line, they would cancel out. So you needed to do it in 2 bits. So first of all, to get this bit, if you integrate between minus 1 and 0, and to get this bit, if you integrate from 0 to 1, you can then add your 2 bits together. So what I've done over here is I have integrated between minus 1 and 0. I've multiplied it out, I've integrated it, I've stuck my values in and I've got it to be a quarter. Then I've integrated from 0 to 1, it's come out to be minus a quarter. But I'm interested in the amount of area, so I'll just call that a quarter. And that quarter worth of area and that quarter worth of area add together to give a half of area. Yes, still there will be method marks and things, yes. Okay. Again, these will go on the KLP if anyone wants a further look. So the next question was question 7, which is a 3-part question. First of all was a straightforward, by looking at it, integrate question. If you wanted to do a sketch, you had a curve, focus, that looked like that, and you were integrating between 3 and 5. There's nothing strange happening. It was just a case of doing the integration, integrating a function between 3 and 5, putting the numbers in, make sure you get them right, and you get an answer of 64 2/3.
How come you did it all in like 64 2/3, and I did it all in like 1/9?
Just the calculator I was using just gave it to me in that form. That's all. I was using an older calculator than the ones you're using, I expect. The next one, part B, that's an integral. There's no limits on there, so it's an indefinite one, so you do need to remember your plus c. So on this one you need to write the half, the square root of y is y to the power of a half, do your integrating, and then any of these answers here are correct. You could either write it down like that, with just a plus sign there at the end with a plus c, or if you wanted to write it with a root sign in it, because there's a root sign at the beginning, you could write it like that. They are correct. And the final one was a definite integral with infinity in it, and the answer was 4. When you integrated it, you got this, and because you're dividing by x squared, when you put infinity in, you're dividing by something massive. That gives you an answer of 0, and you should have got an answer of 4 there altogether. So those were the questions and the answers. So if we just go back through those for some marking.
What's the answer for B then?
B was either of those two.
Can I pointing up there. Instead of a Y?
Yeah, at A level you would lose a mark, but yes, if you've done all the X's, yes. Okay, but they are meant to be Y's. At A level you would lose a mark. Yeah, by testing your integration, not your copying skills. So let's just go back to the beginning then. First question. Shall we say there are 3 marks on each bit of question 1? So question 1 is out of 15. Are we all happy with that? Does anybody need to look at anything in a bit more detail?
15B.
15B, which is this one here. Okay. First of all, I wrote it as x to the minus a half. The minus is the 1 over the half's the square root. Add 1 to the power, so that's a half, and dividing by a half. Dividing by the half is the same as timesing by 2. The power of a half is the square root of x. So substitute a 4 in, and then the 1 in, and that's the answer you should get. Okay? So 15 marks for question 1. The next question, question 3. Shall we say, identifying these two x values, there are 3 marks for getting up to that. So there's 1 mark for the 2, 1 mark for the half, and there's a method mark thrown in there as well. That's 3. And shall we then say, to get the rest of it, shall we say there are 6 marks down there altogether? So 9 marks for that question.
Question 3 is out of 9.
So question 3 is out of 9. So, for example, down here you can give yourself some mark for the rectangle, some mark for the combined area, and a mark for the taking away, and a mark for the answer. If you've got 6 marks to play with, I'll let you grade that one yourself. Okay? So the next question, which was question 4, which was this one, now you had to do the sketching, and they wanted the coordinates. So we say 3 marks for the sketching, because they wanted these coordinates listed. And then the integration itself was a straightforward integration, a bit like question 1 really, so 3 marks for the integrating. No, should we say 4 marks? 4 marks for that. So 7 marks altogether for that question.
I did the graph wrong at the beginning, so I'm going to get no marks.
For the graph bit, yes, you don't get any of those 3
But
there.
then I didn't carry on because I got it wrong, because I got everything else wrong.
Right, did you do some integrating correctly? Did you integrate this?
I integrated...
So did you get that anywhere? Did you get that x to the 4 over 4 minus x squared over 2?
Yeah.
I have a mark for that. Did you substitute anything into it?
Yeah.
What did you stick into it? What
2's and negative 2's.
2's and negative 2's. Okay, you're probably not going to get anything after that.
So 1 mark.
Yeah.
Out of 7.
Yeah. Okay. And the next question then, question 7. These were 3 fairly straightforward ones. So 3 marks, 3 marks, and 3 marks, which makes that 9.
Would you lose 1 mark for not putting add C?
You probably would, yes.
Okay.
So,
What was the...
I reckon we've got a 15, a 9, a 7, and a 9, which is 18, and 15 is 33, and 7 is 40. So I reckon it's out of 40. Okay? So if you could mark that, put your name on the top, put your mark out of 40 on the top, fold it in half, and put it in the plastic wallet that I'm passing around, that would be great.